said expressly, even in the textbook. So we are essentially doing reproduction life cycle of a flowering plant. And obviously your seed has to germinate, and once it flowers, after that the next stage really is pollination. So we've covered pollination, we've covered formation of gametes, and the last day we covered fertilization. And we're going to finish the theory today, and what we'll do is tomorrow it'll be a very short lesson. It'll just be a play some games type things, but hopefully we'll get the theory done today. So after it fertilizes, you need to have seed and fruit formation. From there you need to have seed dispersal. There may be what's called...
Are you taking this down?
Yeah, so page 191, Zara, you should have a gap, or at least it's 191 in mine.
It's 192 in our books.
Oh, thank you so much. So it's 192 in the notes, there should be a gap. And once you do seed dispersal, you will do, or some seeds go through what's called dormancy, where there's no active growth until finally it's going to start again. So we have done these bits, and we're going to finish the rest of the life cycle today. So for each of these things you need to have be able to recognize that these are kind of the sections that the questions are going to come in if they ask them. So we have our gametes made prior to pollination, but fertilization, seed and fruit formation, dispersal, and dormancy. So if you are content with that, I think it must be page 181 that you're going to look for. Just need to find Jazz now for a second.
She just texted me. I think she's struggling to get in.
Could you text her back, Clara, and just tell her she needs to open the link rather than pressing join?
Open the link.
Rather than pressing join.
Join.
Okay, so I'm going to change my share if that's okay. So as I say, we are on page 181, I think, where it now says seed formation. So one of the things they love to ask is what parts of the ovary become which parts of your fruit. That is one of their most favourite things. So this is where we left it the last day. So we'd made our triploid endosperm nucleus and we'd made our zygote. So the zygote is eventually going to become the embryo, and the nucleus, the endosperm nucleus, is going to become a food source. So it's a question of, I have now a zygote is one cell. How does it turn into an embryo? What is what's the word I'm looking for? The type of cell division it's going to do.
Mitosis.
So it's going to undergo mitosis, and this is the exact same with us. So once we're egg meets sperm, for us, we undergo mitosis until you're in your 20s and you're physically fully grown. But in terms of growth. So the ovule is going to become the seed, and your ovary becomes the fruit. And bear in mind that plants have more than one ovule. So if you just look at anything that has like watermelon that has seeds, there's loads of seeds in there. That was loads of ovules once upon a time. And it's the ovary itself that becomes the fruit. And we said the endosperm nucleus, it's also going to undergo mitosis, and it's going to form endosperm. And endosperm is a type of food store, and we're going to talk about that in a little while. Okay, so just to recognize, there are lots of ovules. And everything is doing mitosis. So again, this is also mitosis. So I'm going to click forward. So in terms of then the type of seed structures, we have all seeds will contain an embryo. And as well as having an embryo, all seeds, you can't see the line, so I'm going to draw it in. All seeds will have a plumule. So way back in an earlier last year in fifth form, when we were doing the structure of a flowering plant, we drew something like this for our seed. So this is your plumule, if you want to remind yourself, and that is what's going to become the shoot. And this down here is your radicle, and that is what's going to become the root. So in reality, peanuts are actually a really good thing if you can get your hands on them. If you split open a peanut, so you'll see the line down at the bottom down here, you see, and I'm going to draw it slightly bigger, but you see something that looks like this, and that's actually the embryo in there. And you can sometimes make out the plumule and the radicle, obviously very, very short, but they're really good things to look at. And the other things that will always be in your seed will be a cotyledon. Now, when we did monocots and dicots in fifth form, we said a monocotyledonous plant has one seed leaf. When we talk about a cotyledon in terms of seed, so it is the seed leaf, it's also a food store. So this is the seed leaf in the plant, but in a seed, it's actually a food reservoir. So it'll supply energy during germination for your embryo to grow. And then there are a few seeds which actually come with two food stores, and this is where the endosperm comes in. So that's also a food store or a food reserve. And on the next page, we'll distinguish between our two types of cells. So there are some cells that will only have cotyledon as their food reserve, but there are other types of seeds that actually have two food stores. They have the cotyledon and they'll have the endosperm.
Is there any kind of overarching genus that have endospore, or is it just some specific types of plants?
No, it actually is related to whether or not you're a monocot or a dicot. This determines whether or not, and we'll come to that in a minute. Okay, so if you're happy, hi Jazz, welcome. Glad you made it.
I was late.
It's okay. So
I was trying to figure it out.
Yeah, no, it's click the link, not hit the join. But you got here, so it's all that matters. Okay, so if you're happy with this, so then we go to the two types of seeds. Now you have this as a table on the top of page 182. So in terms of the blurb, an endospermic seed has both endosperm and cotyledon in there, so it has two food stores. And this is their diagram of it. I will draw my terrible version of it. So this is the little embryo down here, the plumule and the radicle. in here is your cotyledon, so that's one food store, cotyledon, and the outside little bit is the endosperm. And usually we see these in monocots. So monocots, while they only have one seed leaf, they have two food stores. Can be a little bit confusing to get your head around. Now the reality is that non-endospermic seed had cotyledon once upon a time. It just got all used up as the seed was developing and as the embryo was growing. So finally, when the seed is ready to be planted, we would draw it this way and we put in our little baby embryo in here. So we'll stick in the testa up here too, if that's okay. So your testa is your seed coat. So it will have a testa, but now all of the endosperm has been used up and it's now converted to cotyledon. So once upon a time there was endosperm present, it just gets used up when the seed is developing. And this is something that you find in dicots. So while dicots have two seed leaves, their seeds have one food store. I'm going to just mute now because my monkeys are coming up.
Just me.
Okay.
Look,
What
I
happened?
got burned.
Doing what? Oven? Okay. Can you leave now because I have to...
The chicken nuggets hurt me.
Okay, off you go. And
I
then...
hate them.
Okay. Okay.
Wait, what's for dinner? Ooh,
We haven't decided. Go.
takeaway. You. Yay.
Okay, sorry about that. Homeschool is over, so it's time to celebrate. So do you have any questions on that? So endosperm, two food stores, but found in the seeds that make one seed leaf. Non-endospermic seeds have just cotyledon, found in dicots that have two seed leaves. Now I am going to give you a few minutes. You should be able to fill in most of the blurb for the differences between monocots and dicots at this point. So that's the table on page 182. So give it a go. So it is 1433. I'll go at 1436. So have a look at it and see where you go. Okay, one more minute. Alrighty, so we'll start going through it. So I'm going to go in order of heads. So Zara, seed leaf for monocot.
1.
Correct. So it's got 1 seed leaf. Peter, you're next up. The venation if you're monocot
What's venation again?
is what do the veins look like in a monocot. So think in the leaf. Put you out of your... So think...
I don't remember.
So you gotta always go back to your example. So monocots, things like grass, maize, tulips. So they have what's called parallel venation.
So the veins all run side by side each other.
Yeah. So if you go look at graphs, you will see that. Andrew, you're up next. Vascular bundle arrangement.
In the monocot is scattered.
Good
in the
man.
stem.
It is. It is scattered vascular bundles. Jazz, you're up next. Flower parts. How many flower parts come in monocots? You remember?
I didn't get that one.
So this is from last year. So flower parts for monocots usually come in 3s. There's 3 petals to them if they have them. We've just done the food store today. So the food store is both cotyledon and endosperm. James, you're up next. So root type in a monocot.
Not sure.
So grass, what type of root does it have versus dandelion? Does that help you anyway?
No, I'm not sure.
Okay, so these guys have fibrous roots. So in terms of their leaves, the veins run parallel, and if you were to see their root, it's all little equally sized roots coming out the bottom. So like spring onion, perfect example. So your examples, grass, maize for my ag, any type of cereal, tulips, spring onions, they're all examples of monocots. So for
Are all bulb plants like daffodils, onions?
yeah, gladioli, all would be monocots.
Any kind of what's the word?
Yeah, that has
It comes back every year.
yeah, that has a bulb.
Okay.
Okay, so for dicots then it's just opposite world. So it has to have 2 seed leaves. What are my veins like? Tig, you're up. Any idea the veins in a dicot?
They're kind of, well, they're not parallel. They're kind of more scattered out, I guess.
Yeah, so
Splayed along the leaf.
yeah, so they use either the word net, so if you hold a leaf up, or they use the word reticulate. They'll accept either. This is obviously the easier one to move. Jess, you're next.
Would you get points by saying like if it's fractal? You know, like how it just kind of it's like one stem and it keeps splitting out and out.
You may, but they really want the idea of net.
Okay.
You may get it, but the type of venation is technically net. The description would be it's like a fractal. Slightly different questions. Jess, the vascular bundles in dicot. Can you remember what they look like?
They're like a circle around the...
Lovely, perfect. So they're in a ring. The flower parts, Velen, you're up next.
Is it 4s?
Yeah, so in at 4s or 5s, so you get way more petals in dicots. We've just done the fact that dicots will only have cotyledon in their seeds. The root type, Flo, you're the next head.
Sorry.
No, it's okay.
Tap.
Yeah, they are tap roots. And then anything that does not have parallel leaves is going to be dicot. So you can pick anything you want. I like carrot because it gives me my big tap root on it. But
Potatoes are monocots, right?
potatoes are dicots, so the shape of the leaf. Yeah.
Oh, okay. I just figured since their roots kind of splay all over the place.
Their roots spray all over the place, but their roots are modified for food storage, you see.
Oh, I see.
Because that's why you get the potato. It's a modified root. But it's the leaf shape. If you look at the leaf shape, the veins on the leaf aren't parallel.
Is oak a dicot?
Oak would be a dicot. Technically, yes. Alrighty, so that was a little bit of revision from Form 5. And now we're just going to go on to the bit that's in fruit formation. So if no one objects, I'm going to change my share. So I'm never sure if this is actually real. Because if this is a tomato, if anyone's ever grown tomatoes, the flowers are really, really small. So the only thing I can think of, it isn't a tomato, but then I have no idea what it is. But it is a really great picture in terms of showing you your fruit formation, because your fruit will form from the girl bits in a flower.
It looks like a lantern fruit.
It's
they look like little orange tomatoes, and they kind of taste like them too. But they actually grow inside their petals.
Okay,
which is why they're called lantern fruit, little paper lantern.
Thank you. I love learning new things. So lantern fruits. There we go. It is real. It's not a Photoshop. So you have to just know what parts of your girl bits become what. So the ovary becomes the fruit. So an apple, I'm loath to use apple as an idea because an apple is a false fruit, but take an orange. So the juicy bits of the orange was once upon a time the ovary. And again, this is really the only plant hormone that we've ever dealt with, but production of auxin helps to form the fruit. So this, I think, is supposed to be a pear, and it's showing you similar picture. So the zygote becomes the seed, which you want to plant. The ovary wall becomes the wall of your fruit, and this can be called a pericarp. So if you see that in a question. What is the point of putting all of that energy into making fruit? Why would they bother?
To attract animals so that the seeds are spread.
Yeah, so, and there's also
birds and grazers and stuff like that.
Yeah, so first and foremost, they want to protect the seed as much as they can, and then they want to encourage seed dispersal away from the parents as much as they can. And once the fruit has formed, the flower has done its job, so it's going to disappear. So we have the zygote is becoming the seed, the ovary wall is the wall of your fruit, and your ovary is the actual physical fruit. So this diagram here, pears are also false fruits, because this is the ovary here, whereas this part is not. So we'll talk about them in a second. So if you are happy,
is that why the cores of apples and pears and other kinds of fruits are so tough? Like their flesh is tougher around the seed area.
Yep, it is, but it's just how the fruit itself is made. The fruit comes from the floral parts rather than from the ovary. Technically, you can.
Does that make it a berry or?
No, technically you can eat the ovary of an apple. You may not enjoy it, but you can certainly eat it. So, just in terms of things that are called false fruits, so they develop from other parts of your flower beside your ovary, and the apple is the most common example. So, it's actually the flower parts that swell with stored food, and it's the core that is the ovary.
Is that to like mitigate anything in particular, or just
evolution, the way it worked? So if you can remember back to fifth form when we do the structure of the plant, the receptacle is the part that supports your flower. They're supported on that part of it, and in apples they are the things that swell with food. So seedless fruits became a thing. I don't think you ever know the emotional scarring that results from eating grapes that contain seeds in them. Because seedless grapes are now a big thing.
That's a GMO thing, right? Where they just stop the seed formation halfway through.
It is not necessarily genetically modified. It can be naturally done. It's not necessarily something that's artificial. You can do it artificially, but it's also you can breed your plant to not make seeds. So
Miss, can you go back for 2 seconds? Sorry. Thanks. Alright.
alrighty, so there's two ways. You can either naturally breed your plant to become seedless, or you can artificially do it. So seedless oranges have been done that way. Things like seedless grapes, they will spray your plant with growth regulators so that the fruit doesn't need, it'll form without having to be fertilized, so there's no seed that's going to be present, and you see that really in seedless grapes. What is the advantage of making seedless fruit?
Maybe it attracts animals more often.
Well, think,
outside of the actual germination period.
but if you're artificially doing it, why do they bother? So for us as consumers, anyone else have any ideas? For us as consumers,
You don't have to wait for natural pollination.
yeah, so it's going to be much faster because there's no pollinators, so that's going to be more profit for you. So economically it's more profitable, more profitable, and again, I am the era of emotional scarring from eating seeded fruit. Some people just don't like to eat seeds. So
isn't that like a whole issue though when it comes to stuff like grains with terminator crops?
Don't know.
You know, like where they engineer the seed to not produce fertile seeds or seeds at all, so that there's no like issue of genetically modified plants getting into the other plants in the area. I don't know.
Into the area.
There's like some mercurial strange reason for it.
Well, I think if you're a commercial grower, you want to make seeds because that's how you make your money. Otherwise, then it just becomes about what's your market and who wants to eat what.
Millennials.
Yeah, I won't say you're soft, but you're pampered.
Hey.
So
Nice.
harsh but true. So page 183 at the bottom. So this will just be the summary. So where are we on heads? Mark, you're the next head. So the ovule, what does that become? You may have to flip back a page.
An ovary, is it?
So the ovule. So the ovary becomes the fruit. What does the ovule? So ovaries contain...
It's flower.
Nope. So we're talking now about making seeds and fruit. So if we draw this again, the last day, so sigma style, you have your ovary, and in your ovary you'll have loads of ovules, and the ovules is where fertilization happens. So what does the embryo turn into?
A seed.
Becomes your seed. I'm going to change my share if that's okay. Okay, so your ovule becomes your seeds. So the integuments, when we drew this diagram, we drew two little lines underneath our ovary, and there was a little hole going into it, and the two little lines are the things called the integuments. So I'm going to help you out there. They become, okay, this is not going to animate, they become your testa or your seed coat. Can anyone remember what the nucellus was that was up in this little diagram?
Was when the what was that? That was the Wasn't that the food store ones, the poorer ones?
So it's not, it's in the girl bits, and it is the food store, and its equivalent is endosperm and cotyledon in your seed. So this is before fertilization. The nucellus is what your female gametes are using as energy source, and once you fertilize, your embryo is going to use the energy from your endosperm and your cotyledon. So the egg becomes the zygote, becomes the embryo, and we've said the polar nuclei become the endosperm, ovary becomes the fruit, and the ovary wall becomes your fruit coat. Where are we on time? So I am gonna give you 8 minutes break to catch up on your texting and what's going on in the world. So if you want to shut off your cameras and your mics, and I'll see you here at 3 o'clock. Or you can talk to each other. I'll shut down my camera in a second, and I'll mute myself now. I can still hear you though, unfortunately, but you can use the chat feature.